Hello and welcome to the video. In this video, we are going to talk through the process of solving inequalities and presenting our answer as an inequality and also on a number line. Before we start with that though, I would like to do a recap on solving equations. So I've presented 6 equations on this slide. The 2 red equations are the easiest. The 2 green equations are the most complex. What I would like you to do is have a go at the 2 most challenging equations that you can solve. Remembering that we need to balance each side of the equation. So we've got some 2-step equations up here. We've got some expansion of brackets, and we also have some equations here that involve 2 unknowns. Okay, could you have a go at the 2 most difficult equations you are confident with? Could you pause the video now, please? Okay, welcome back. Let's have a quick look at my answers. My answers look like this. So hopefully you have reminded yourself of the process of solving equations, and you can go ahead and assess your work just by looking at my solutions and making sure they are correct. Okay, that leads us nicely into the lesson, because we're going to talk about solving linear inequalities. On the previous slides, we looked at linear equations. Okay, and the reason we learned how to solve linear inequalities is basically for this bit here, the last part of the box, because whatever you can do to an equation, we can also do to an inequality. So the process of solving equations is very similar to the process of solving an inequality. However, inequalities help us to consider a wider range of potential answers to the problem. So for example, on the previous slide, you may have told me that the answer was 7 and only 7. You may have told me that the answer was 2 and only 2. But when we start talking about inequalities, we start talking about a range of answers. So the variable x or y or a has more than one exact answer. It has a range of answers. Okay, first thing we need to discuss is the inequality signs that we will be using throughout the video. If we look at the red box here, we've got x is less than 9. So this inequality sign here, that reads as less than. Less than. And one way to remember that is if we look at the wide part of the inequality sign, so you can see this bit is quite wide, and that is aimed towards the 9. This part of the inequality sign is pointed, it's very narrow, and that's aimed towards the x. So the wider sign of the inequality always points towards the bigger thing. So this is telling me that x is smaller than 9. X is smaller than 9. Okay. If we look at the second one here, the inequality sign is the other way around. We've got y is greater than -1. Again, we've got the wide side of the inequality sign, so that is next to the bigger side of the inequality. So this is telling me y must be bigger. Y is greater than, there's the narrow side, -1. Y is greater than -1. If we look at the third one down here, we now have this addition of the line underneath the inequality sign, and that just changes the wording that we are going to use. A is greater than 7, so very similar to the way we word this one, but now because of that line, we need to include A is greater than or equal to 7. So this line underneath corresponds to or equal to. So A is greater than or equal to 7. I've also asked here to give 4 integers that satisfy these inequalities. The word integer means whole number. So I'm looking for 4 whole numbers that would satisfy each inequality. So if I read this one again, x is less than 9. So I can come up with any integer, any whole number that is less than 9. Remember, 9 is not included because there's no line underneath the inequality sign. So if I wanted to give 4 integers that satisfy this inequality, I could say 8, 7, 6, and 5. Of course, I could say minus a million, minus 234. They would also satisfy the inequality, but I only asked for 4. If I want 4 integers that satisfy this inequality, I want 4 numbers, 4 whole numbers that are greater than -1. So I may just give 2, 4, 6, and 8. 4 integers that are greater than -1. Of course, there are lots and lots to choose from. There is actually an infinite amount of integers that would satisfy that inequality, but I've only asked for 4. 0 would also satisfy this inequality, but remember, -1 would not, because -1 is not included. There's not a line under the inequality sign. A is greater than or equal to 7. If I'm thinking of 4 integers, I can go for 8, 9, 10, but I can also include 7 this time because A is greater than or equal to 7. Again, there would be an infinite amount of integers that satisfied the inequality, but you could just go for 7, 8, 9, and 10. Okay. So now we're going to talk through solving some inequalities, starting with some very basic ones, then we'll get a little bit more complicated. And once we've solved each inequality, I want us to write down or come up with 4 integers that would satisfy the inequality. Here's my inequality, and I'm going to treat it exactly like an equation. So if there was an equal sign there, how would we solve this equation? We're going to do exactly the same process. So first of all, I'm going to look at this plus 5, and I'm going to subtract 5 from this side at the same time subtracting 5 from that side. So I've balanced my equation by subtracting 5 from each side. That's also the case of having a plus 5, moving it over the equal sign, and changing it to a -5. Once I tidy this up, 9 minus 5 is 4. So this now reads as y is less than 4. So if I want 4 integers when y is less than 4, I could go for 3, 2, 1, and 0. I could also present my answer on a number line. So I've wrote a number line here from -5 up to 5, and I've put a circle at 4. Notice that the circle is not shaded, it is empty. And an empty circle depicts this inequality sign. So it's less than 4, but because it's not shaded, it is not equal to. And then I've just put an arrow pointing this way, which is telling me that any integer, any number this side of my circle would satisfy this inequality. So I could say 3, 2, 1, and 0, but I could also say any number in this direction. So y is less than 4 is exactly what is shown visually on this number line. Because of the direction of the arrow and because the circle is not shaded in. Okay, let's try another one here. So first of all, I'm going to treat this like an equation. I'm going to solve the equation. I'm going to start by subtracting 2 from each side. So that is the same as taking the plus 2, moving it over here, making it a -2. Just going to tidy that up to become 8. So at the minute, I've got 2y is less than or equal to 8. Now I'm just going to divide each side by 2. Now I'm going to finish that off. So this now reads as y is less than or equal to 4. So if I wanted 4 integers which satisfied this inequality, I could say 3, 2, and 1. But I could also say the number 4, because this time it is included because of that extra line under the inequality sign. If I was to go ahead and present this on a number line, I've got my arrow in the direction here, telling me that any integer in this direction would satisfy my inequality. But if you look at my circle, you will see that it's shaded in this time. And a shaded in circle above the 4 represents that the 4 could be included. So y is less than or equal to 4 is exactly what's shown visually here, due to the direction of the arrow and the nature of the shaded in circle. Okay, so here's 2 more questions for you to have a go at. I am going to talk through both answers of how to solve the inequality and how to present your answer on a number line. But if you do want to have a go at these questions yourself, please pause the video now. Okay, I'm going to look at this question first. So here is my solution. So I went ahead and solved the inequality. First thing I did was I subtracted 2 from both sides. Then I tidied it up to get a negative 10. Then I divided both sides by 5. So I was left with a is less than or equal to negative 2. So this was my answer to the inequality. So if I was thinking of integers that satisfied this inequality, I could think of -3, -4, and even -2 would be included because of this line underneath the inequality sign. Then I went ahead and drew my answer on a number line. I've got my arrow pointing in this direction because I want numbers less than -2, and my circle lands on the number -2 and it is shaded in because -2 is included. So a is less than or equal to -2 is represented by this arrow on the number line. Arrow in this direction, shaded circle above -2. So any answer down here would satisfy this inequality. Okay, let's have a look at the second one. So first thing I'm going to do is I'm going to subtract 7 from each side, because remember I'm aiming to get the variable a by itself. Once I tidy that up, I'm left with 6 a's are greater than -6. Then I'm going to divide each side by 6. Once I tidy that up, I will be left with a is greater than -1. So again, if I'm thinking of integers that satisfy this inequality, I could think of 0, 1, 2, 3, 4, but I could not include -1 because the little line under the inequality sign is not present. If I wanted to show this on a number line, it would look like this. I've got my circle above -1. This time the circle is not shaded in, which corresponds to the line not being present underneath here. And the arrow is pointed in the opposite direction because I want numbers that are bigger than -1, greater than -1. So a is greater than -1 is shown by this arrow on the number line. Any number in this direction would satisfy this inequality. And remember, these numbers would go on for infinity. So there is lots of integers and numbers that would satisfy this inequality. Okay, quickly before I give you a task to work through, I would like you to pause the video at this point and just write down as an inequality what is represented on each number line. So just a quick recap, what is each number line representing? Could you tell me that or show me that as a written inequality? Could you pause the video now? Okay, welcome back. If we look at the first one, we can see that it's a shaded circle and we are looking for numbers greater than. So your inequality could look something like this. You could have used any letter. I've chose to use an A. And I've also asked if you can verbalize what it says. Can you speak and tell me what it says? So if I was to read this, A is greater than or equal to -2. Greater than or equal because it is a shaded in circle, and the arrow is pointing above because we want numbers greater than -2. For the second one down, we are going to be values less than -1, and this time it's not equal to because we've got an empty circle. So if I wanted to verbalize this, if I wanted to speak this, it would be A is less than -1. Empty circle, no line underneath the inequality sign. For this one here, it would be, it's going to be equal to as well because we've got a shaded circle and we're looking for numbers greater than. A is greater than or equal to 1, which is why my circle is above the 1. It's why it's shaded in, and it's why the arrow goes in this direction. For the one at the bottom, first time we've encountered one of these in this video, but hopefully you were able to put it together. I'm looking for numbers that satisfy both of these circles, so to speak. So we've got numbers that are greater than -4, but not equal to, and numbers that are less than or equal to 2. So I'm putting two inequalities and sort of putting them together to create a range of numbers that would satisfy the inequality. So it would look something like this. So if I went ahead to read this, it would be that A is greater than -4. A is also less than or equal to 2, which is exactly what is depicted in this number line. Okay, so here is a task for you to have a go at. For each question, each inequality is in a green box. For each inequality, I would like you to show your full working out and solve the inequality. Once you have your solution for the inequality, so you know what range of answers would be acceptable, I would like you to match that up to the correct number line. So for each question, I want to see some full working out and then you correctly matching up your answer with the number line that shows the range of acceptable answers that would satisfy each inequality. Could you pause the video and have a go at this task now? Okay, welcome back. So we don't really need to go through lots of solutions for this task because if your answer was correct, your working out was correct, it should have matched up with one of the available answers. So this task is self-marked because if it's matching up to a number line that's displayed on the screen, then we can presume you got your answer correct. Okay, over the next few slides, there's going to be 6 inequalities for you to solve. Again, just for a little bit extra practice to try and improve your confidence with solving inequalities. So for each set of 2, could you pause the video and then I will display my answers. Could you pause the video now, please? Okay, so for the first question here, I have a result of A is greater than 3. I would subtract 4 from each side, so I'd be left with 9A is greater than 27. Then I would divide by 9 to be left with A is greater than 3. Over here, we have 2 options of approaching the question. We could divide each side by 6 to be left with -2 on this side, or we could start this question by expanding the brackets before we went ahead and solved the inequality. Either way, we should end up with the same result. A is greater than -1. 2 more inequalities for you to have a go at. Could you pause the video and solve both the inequalities on the screen? Okay. Welcome back. For the first one, I have an answer of A is greater than 4. So what I would do here is I take this 2a, subtract it from this side. At the same time, I'm going to subtract 2a from this side. So I'm going to be left with 4a's are greater than 16. Then I divide by 4 to tell me that a is greater than 4. Over here, we're dealing with two unknowns. So we've got two y's in the question. So I would subtract 2y from here, at the same time subtracting 2y from this side. I would subtract 3 from here, at the same time subtracting 3 from this side. So I'm going to be left with 2y's are less than negative 19, which means when I divide by 2, y is less than negative 9.5, negative 9.5. Very well done if you were able to solve that inequality. Two more to have a go at, and we're getting a little bit complex on the green question here with expansion of brackets needed and two unknowns involved. Could you pause the video at this point and have a go at solving the inequality? Okay, welcome back. So on this side, I would subtract a from this side, at the same time subtracting 1a from here. I would add 5 to this side, at the same time adding 5 to this side. So I'm going to be left with a is less than or equal to 6. So remember that extra little line, or equal to 6. There's my range of answers that would satisfy this inequality. For the green question, we should go ahead and expand the brackets. So our question is going to be 5a minus 5 is greater than 3a plus 18. From there, we can treat it as an equation with two unknowns. Solving it like an equation, but of course it is an inequality because we're dealing with an inequality sign. Once we work through the question, we would find our range of answers that satisfy this inequality is when a is greater than 11.5, 11.5. Very well done if you were able to get both ranges of answers for these questions. There is one type of question that I haven't included in this video, but I still want to go over the process so you are aware of when this method would occur and when this method would be applied, because you may find it on worksheets, you may find it in exam questions as you study this topic in more depth. So if I give you this inequality, minus 3y minus 2 is less than 13. As we've been doing on the previous slides, I'm going to go ahead and solve this inequality. So the first step is I'm going to take the minus 2 and move it over here. So I'm adding 2 to this side. At the same time, I'm going to add 2 to the other side. 13 plus 2 on this side, I'm just going to simplify that to 15. So my inequality now reads minus 3y is less than 15. That's all well and good. Now I'm going to divide by negative 3 so I'm just dealing with one variable. So I'm going to divide this side by negative 3. At the same time, I'm going to divide this side by negative 3. There we go. And I've divided this side by negative 3. And this is when we have a subtle difference in our working out, in our method. When you are dividing both sides by a negative number, so I divided this side by negative 3, and I've also divided this side by negative 3. During an inequality question, if that ever happens, the inequality sign, the direction is reversed. The direction is flipped. So my answer to this inequality would actually be y is greater than minus 5. So even though on the previous line here, it was negative 3y's are less than 15, because at this point I divided both sides by a negative number, my inequality sign flipped. It was reversed. So my answer now reads as y is greater than negative 5. So then I could go ahead and draw my number line or give my integer answers based on this inequality. The reason we flip the inequality sign, it's linked closely to the way our number line works. So for example, the number 20 is greater than 5, but the number minus 20 is less than minus 5. So the way our number line works in mathematics, it just causes this little bit of confusion, which results in when you divide both sides by a negative number, the inequality sign must be flipped. Let's have a little look at that from the answer we may have got. So if you did not flip the inequality sign, we would end up with this answer. Y is less than minus 5. So let's try substituting a value into here and see if it makes mathematical sense. So y is less than minus 5. Okay, so I could use minus 6, negative 6. So if I substitute negative 6 into here, negative 3 times negative 6 would be positive 18. Then if I took away 2, I'd be on positive 16. So now I would be saying 16 is less than 13, which mathematically does not make sense. Mathematically, that's incorrect. So if you don't flip the inequality sign, what you find is the integers that you think satisfy the inequality, when you actually substitute them into the inequality, it will no longer make mathematical sense. So please remember, when you're dividing an inequality, when you're dividing both sides by a negative number, the inequality sign must be reversed. So for the last task of this video, we're going to make things just a little bit more complex. So we're going to look at three-part inequalities. So this inequality states that 2x is greater than 10 and 2x is also less than x plus 9. So we need to be able to solve a three-part inequality and give integer solutions or even present our answer on a number line. Three-part inequalities are now a very, very common exam question. This is how we would approach a question like this. We're going to split it into two separate inequalities. So at first, I'm going to forget about that part of the inequality and just deal with 10 is less than 2x. So I'm just going to solve that. I'm going to divide each side by 2. So I find that 5 is less than x, or we could state that x is greater than 5. So we've solved this side of the inequality. Then we're going to solve the other side of the inequality. So this time I'm going to forget about or ignore the 10, and I'm going to solve this inequality. 2x is less than x plus 9. So if 2x is less than x plus 9, I'm going to subtract an x from each side, which is going to leave me with x is less than 9. So now we know two things about x. We know x is greater than 5, or we could read that as 5 is less than x. And we also know that x is less than 9. So if the question was to say, list the integers that satisfy these inequalities, I'm looking for numbers that are greater than 5, but also less than x. Whole numbers in between 5 and 9, but 5 and 9 are not included. So my answer for integers that satisfy this inequality would be 6, 7, and 8. So when we are given a three-part inequality, how we approach it is we split it into two separate questions. We deal with the first half of the inequality, then separately we deal with the second half of the inequality, then we can go ahead and answer the question that has been asked. Another example from me. So this time we've got the inequality that reads 4 plus x is less than 3x. 3x is less than or equal to 2x plus 5. Again, I'm going to split it into two separate inequalities. So I'm going to ignore this bit for now and deal with 4 plus x is less than 3x, or we could read that as 3x is greater than x plus 4. So if I'm going to subtract an x from each side, so that's going to leave me with 4 is less than 2x. Then I'm going to divide each side by 2. So I'm left with 2 is less than x, or we could read that as x is greater than 2. You can just about see on the other side of my screen that I've started the second part of this question. So this time I'm going to forget about this section and I'm going to solve this inequality. 3x is less than or equal to 2x plus 5. I'm going to subtract 2x from each side, which is going to leave me with x is less than or equal to 5. So this time, if I wanted to list the integers, I would be looking for numbers that are bigger than 2, greater than 2, but 2 is not included, and also less than 5, but this time 5 is included. This time I've been asked to present my answer on a number line, so a slightly different way of presenting my answer. My number line would look like this. X is less than or equal to 5, is shown by this shaded in circle above the 5, and x is greater than 2 is shown by this empty circle above the 2, and they are connected with a line. There's no arrow this time because the range of numbers and integers that satisfy this inequality is not infinite this time. This time there is a definite number of integers that would satisfy. And the 3 integers that would satisfy this inequality would be 3, 4, and we would also include 5 because of this shaded in circle. Okay. Another task for you to have a go at. So on the screen, I've displayed 9 3-part inequalities. For each question, I would like you to solve the inequality by splitting it into 2 separate questions. Once you have your solution and your range of numbers, your range of integers, I would like you to tell me all the integers that satisfy the 3-part inequality. And I would also like you to present your answer on a number line. So for each question, I want to see full working out, a list of integers that satisfy the inequality, and also a number line solution. Okay, could you pause the video at this point and have a go at the 9 questions on the screen? Okay, welcome back. Just going to have a look at my solutions to each of these 9 questions. Here are my solutions. So I've shown you my full written solution, how I've approached the question and split each question into 2 parts. Then I've listed all of the integers that would satisfy the inequality, and I've also went ahead and presented my answer on number lines. You have the ability to pause the video at this point if you need to see my solutions and my number lines for a little bit longer. But once you have marked them up, if you were able to get all 9 correct, then that is brilliant. You've shown a very good understanding of solving inequalities.